we saw in the method signatures that methods had a return type, and the return type tells you what to expect when the method is to finish executing. But how do we tell the method that we're creating ourselves to return something to the calling method? Well, this is where return statements come in. The return statements allow you to pass a variable from the method back to the place where the method was originally called. So let's take a look at an example of that. Here you can see the return type in the method heading. And you can see how we return that type. Note that as soon as this method returns a type, it ends the execution and returns to the calling method. So you may have, or if you have any statements after the return statement, they won't be executed. This is most frequently happens when we have a loop or some other branching control structure. And in this example, the age variable obviously is an int. And if it wasn't, the compiler would complain when we tried to compile the program, telling us that there was a mismatch between the heading and the return type. Now, from the driver program, we can see our object, Mickey in this case, calling the getAge method. That value is returned is used as an argument to the printf method and will be plugged into the first format specifier. So getWeight is going to, getAge is going to get plugged into this format specifier, right? So we've already looked at all that. And likewise, getWeight is going to get plugged into the second format specifier right there, okay? And turning to our mouse to class again, you can see example of the void return type in the grow method. And you can see that here. So a void return type is what you use when you want to specify that you're returning nothing. And you can notice that at the bottom of our method right here, we have no return. It just ends. For methods with a void return type, it's legal to have an empty return statement. The empty return statement looks like this. On the left, you see our method without the empty return, and on the right side, you see it with it. The empty return statement does exactly what you would expect. It terminates the current method and causes control to be passed back to the calling method at the point that immediately follows the method call that called the current method. All right, sounds confusing, but it's really not. So let's take a look at a practical example of this, and hopefully it'll clear it up. Suppose you'd like to model mouse growth only up to through the mouse's adolescence. So here we're going to have this method called grow, and we're going to stop after 100 days. So you can see that right here. If this age is greater than or equal to 100, return, which means we're going to leave this method altogether at that point. It's not going to execute any of this stuff down here, right? So that's our empty return statement. Now, code that uses empty return statements can always be replaced by code that does not use an empty return statement. For example, here's a returnless version of the previous grow method. Notice how we pulled the logic to check if the age was greater than 100 out of the while loop. Before, this part right here was down inside of this while. And so we moved it out of the while loop to prevent us from having to have that empty return statement. So which of these two ways of writing this method would be considered to be better? Option A, with the return statement baked in, or option 2, without it? Programming in the real world or out in the wild, you're often asked to maintain, fix, or improve other people's code. And in doing this, you often have to find yourself examining loops and their loop termination conditions, right? And so this is often, or usually, it's going to be in the loop header. So like up here in the while loop, or if you had a do loop, it'd be down at the bottom in the do loop termination conditions, right? Or if you had a for loop, it would be in the for loop header. So what this does right here, by adding this empty return statement, is it introduces this extra termination place that now you have to pay attention for and you have to look for, right? So with that being said, you should exercise caution when adding in an empty return statement into your code. Now, if using this return statement adds clarity to the code and it makes it easier to understand, then do it. If it just makes the coding easier but doesn't necessarily add clarity to it, then do not. Stick with this method over here where you pull the condition outside of the while loop, okay? So we talked about local variables and we talked about default values before, but what are the default values for local variables? Well, as you can see on the screen, the default value for a local variable, no, not an instance variable, local, the variable is initialized with garbage. It's what happens to be in that memory location when you first declare it. So it is exactly that. It's full of garbage. And so when you're doing a program trace and you come upon a uninitialized local variable, again, I got to stress this, a local variable, not a instance variable, you're going to want to use a question mark to indicate that the contents are unknown and it hasn't been initialized with the default value. If a program attempts to access a variable that contains garbage, the compiler will generate an error. So we're going to take a look at the difference between a local and instance variable and how the default values are used in a program. Okay, so here we have a really complicated program. We have a default value class, and in it we have a public num1, and actually using good encapsulation we should actually make this private. So we have a private num1, and then we have our main method. So what we're doing here is we are creating a instance of the default value class. So this is our class, and we are using the constructor, which we're going to get into later, to create a instantiated object. Okay, so we have test, which is a of type default value, right? And so we are printing out its attribute. So right here we have its member variable num1, and see how we are accessing it with the dot notation. So test1 is saying, okay, give me whatever's in num1, and we're going to print it out. So let's go ahead and compile it. It compiled successfully, and we're going to run it. And you can see here num1 equals 0. All right. So that is a instance variable. All right. Let's, to be clear, instance variable. Okay. Now down here we have a local variable. Why is it local? Because it's inside of, get my spacing right, because it's inside of the main method. Okay, so num2 is local to this method. All right, so if we try compiling this now, because it has not been initialized, look what happens. Hey, error, variable num2 might not have been initialized. If we scroll over, might not have been initialized, right? So right there it tells you that you can't do it. So now if we say, okay, all right, we're going to set it equal to 0, and we're going to, now it compiles and now it runs. Look at that. So that is the difference between local variables and instance variables when it comes to initialization values. Remember, ints are, or integers are defaulted to 0, floats are defaulted to 0.0, and reference types are defaulted to null. Okay, that's for instance variables. For local variables, there is no default value, and you must initialize them at some point in your program before they are used. So now we're going to get to something that confuses a lot of people, and it is, I don't want to say it's confusing, but it can be if you make it. So Java uses what's called pass by value mechanism to pass arguments to methods. And pass by value means that the JVM passes a copy of the argument's value, not the argument itself, to the parameter, to the method that's going to be using it. So if the parameter's value changes inside of the method, the argument in the calling method is ineffective. So we're going to take a look at a demo of this using the mouse3 driver. And I want you to pay attention that even though the day's value within the grow method changes, the main method's day value is unaffected. So let's go ahead and take a look at the mouse3 driver program. Okay, so here's a nice easy program for you. Here we have the mouse3 driver. And in it, we're going to create a new mouse3 object called mini. So we create the object and assign its memory location to mini. And then we have a local variable called called days, and that's initialized to 365. And then we're going to call grow and pass in the number of days. Now, when we talk about pass by value, when we pass in days, we are not actually passing in the days variable, right? We are passing in a copy of the information that's stored in days. So we are passing in 365. Now, in some other languages, if you do this, you would actually be passing in the memory reference, and so you would alter days. But here we're not actually passing in days, we're just passing in what's stored in days. So again, this is pass by value, not pass by reference. And if we take a look at mouse3, you'll see here we have mouse3 and we have some instance variables. Age set to 0, weight is set to 1.0, growth rate is set to 10%. And then if we come down here and look at days, it's going to take a variable called days. And notice we're using the same variable name, but they're not actually the same variable. Context matters. So this days is local to this method. And so here we're passing in days, and it is going to add its age, or add the number of days that is passed in to its age, right? So whatever, if its age was 10 at this point, and we passed in 30, well, now this age would be equal to 40. And so while days is greater than 0, so if we pass in 40, it's going to count down from 40 until 1, and it's going to calculate its weight and update its weight accordingly, and then it's going to subtract 1 from the days, and then it's going to keep doing that until it gets down to 0, and when it gets to 0, it's not going to do it anymore. Okay, so if we run this program, if we hit Control 2 and we run it, you'll see that the number of days aged is 365. So if they were using the same variable, when we passed in days here, days would have gotten decremented 365 times. And so when we moved it over here, it would have printed out 0. But in fact, we did not pass in the days variable. We only passed in a copy of the information, which was 365, into the days variable. That information then got stored in this local days variable, and then it gets utilized here. Okay, so hopefully that clears it up. It can be confusing if we change the names. So say we say number of days to grow, right? So now we've got this long variable name, and we're going to pass that in, and you can see that we can change anywhere where we use days to number of days to grow, and we compile it and we run it. Oops, we can't run the mouse class. If we run this, right, you'll see we get the same result because we didn't actually change anything. But now it's a little bit more apparent. We're going to pass in this 365 days, and that information gets copied into this new temporary variable that we've created. Now finally, the last thing I want to talk to you about in this unit is specialized methods. And there are 3 specialized methods that we're going to discuss, and those are the accessor, the mutator, and the Boolean methods. Accessor methods simply get or access the value of an instance variable, as shown in this example. So here we got get age. Okay, well, return this age. Pretty straightforward, and that's usually, I mean, that's about as bare bones as you can get. Now, typically, we might add a lot of additional logic checks and other things to this method, but for now, this is simply all it does. We have a private variable called age, and we are creating a public method that is going to allow us to access that private variable, but it allows us to control how it gets accessed, and that's the important thing. We also have mutator methods, and they simply set or mutate the value of an instance variable, right? And so it's, again, should be fairly self-explanatory. We're going to use it to modify the value. So again, we have a public method, and notice that its return type is void. We're not expecting anything back because we're doing something to the object, okay? We're not getting anything from the object. Where here, we're expecting an integer because we know that the age variable is an integer. So, we want to return that it's an integer, otherwise it won't compile. So down here we have set percent growth, and we're passing in a value. We're passing in this double percent growth. And remember, this is the context. It says this object, we are going to set its percent growth rate to whatever was passed in, right? Notice, and this can be confusing, notice that these variable names are the same, right? And that's fine as long as we're using this prefix to denote that we are modifying the variable that belongs to the object, okay? This right here, this percent growth rate, is a local variable, okay? And so if you didn't have this, it would just say, okay, you're setting me equal to myself. Well, okay, and it would do it happily. It just would say, okay, well, if percent growth rate is 10, well, percent growth rate is now 10, all right? So this keyword is what allows you to use the same variable name, because this one is a local variable, local to the set percent growth rate method, and it gets stored in the object's percent growth rate. So I want to be clear on that because some people get confused. So that's what a mutator method does. It allows us to add logic to control how we are going to access, or excuse me, to mutate the member variable. And again, just like the accessor method or the get method, this allows us to throw in, we can add a lot of logic checks, a lot of verification. We want to make sure that the information that we're getting in makes sense, right? If say you have an age variable, you don't want somebody to set this equal to -10, right? You can't be -10. So you want to add in some logic to say, hey, make sure this variable is greater than 0. Otherwise, return an error or do some kind of error handling. And we'll get into error handling next semester. But just, I want you to understand why we're doing this, because it seems like, well, why don't you just access the variable? It seems stupid to actually write all this extra code just to change this thing when all you're doing is just doing this one line to change it. Okay, well, it's there for a reason, because people do dumb things. Never trust the user. That's tenet number 1 of programming. And so this is why we have mutator methods. Now, Boolean methods are used to check if a condition is true or false. And they normally start with is and always returns a Boolean value, right? So they check whether something is going to be true or falsy, or the falsity. I always want to say the truthiness, if anybody likes Stephen Colbert. They want to check the truthiness of some condition. But they always return a Boolean value, and they usually start with is. So if we take a look at an example, we could use this with our mouse. We've been looking at this mouse class, this whole unit. Is adolescent. Okay, well, we're considering an adolescent in a mouse to be less than 100, or equal to, less than or equal to 100. So if the mouse is adolescent, calling the is adolescent mouse or method will return either true or false, right? And that's it. That's all there is to it. It's just usually, it's some easy way to give a positive check, yes or no, is this condition true? What is the state of this mouse? Is the state of this mouse an adolescent, or is it an adult? Okay, well, this is how you could check. You could do the same thing. You could say is adult and is age greater than 100, right? So there we go. There's an example of it being used in an actual driver program, right? We're going to create this mouse called Pinky, and if Pinky is an adolescent, then we're going to do something, right? Otherwise, we're going to skip down here, okay? So that's it. All right, so that's Unit 6, Object-Oriented Programming. We talked about, we gave you a broad overview of what object-oriented programming is. Obviously, the book's going to be a lot more in depth, but this is the crash course, the too long didn't read version of it. We talked about UML class diagrams and we looked at your first object-oriented programming class. And we talked about member access, private and public. We also talked about how to use a driver class, how to write a program that uses other objects instead of just using the main method from each class. We also talked about reference variables and instantiation. Again, reference variables are those things that are not primitive variables. So anything that's we have to create using the keyword new. Okay, with the exception of strings, that's a different case. Calling a method, we talked about that. Calling objects, we talked about the this reference, okay, quite a bit. We also talked about default values and the difference in initializing local variables versus instance variables. We talked about variable persistence and how things will last as long as the object that created them lasts. And then we got into a little bit more detail about UML class diagrams. Again, we are only talking about class diagrams here. Know that there's a lot more diagrams out there that UML uses to help define a software architecture. And then we talked about local variables, and again, the difference between local variables and instance variables. And then finally, we got into how to use the return statement to make sure that you are, returning something back to the object that called it. And we're going to look at this next semester, something that's really cool called method chaining, and how you can return a copy of the object itself when the method is done. And so you can call one method after the next after the next. And so it's pretty neat. But again, that's next semester. Don't let me get ahead of myself. We talked about argument passing and how Java is considered passed by value and not passed by reference. When we start getting into the C++, then we'll start talking about passed by reference. And when we start talking into passing objects in Java, that's passed by reference too. But we'll clarify that up when we get there. Specialized methods, we talked about accessor and mutator methods as well as Boolean methods and how they always return a true or false and always starts with an is. So hopefully you found these videos helpful. If not, let me know in class and let me know how I can improve them so we can have a better class. Thanks.